So I'm doing something a bit different today, and this is going to be a bit more ad hoc than usual. I want to give you a talk that I've given a few times in real life. That does mean though, as a quick disclaimer, if you watch my stuff normally, you'll be used to me talking about Rust. Today, the code examples are going to sort of be in TypeScript. There's a bit of pseudocode in there. The examples don't exactly work, but shh, don't tell anyone, all right? Now, I want to talk to you about why I don't mock. This is going to be controversial, but I'm hoping by the end of it, you might be doubting mocks too. Let's start at the beginning, right? Unit tests are awesome. If you have watched any of my previous content, or if you've met me in real life, you probably know that I love tests. I struggle a little bit with imposter syndrome, and I don't necessarily believe people when they're telling me that I'm doing a good job. But if I write a unit test that makes sure that my code does what I think I want it to do, and then the test passes, and the computer tells me I did a good job, then I feel good about that. So let's do that together right now. We're going to write a contrived little function. It's going to take a user the first time that we see them, and then it's going to return a little greeting to that user. Really simple. So our test is simply going to create an arbitrary user for us, and then we're going to pass that user into our function and test that what we expect to get back is what we get back. This is dead simple. We run our test, the test passes, Daniel feels good about himself, and we move on. Now, in computing, generally in programming, and particularly in web tech, which is the area that I'm from, our software never stands alone. It always wants to talk to something, whether that's a user or a data store, whether that's a database or a block storage or an API somewhere or cache or something. We're always talking to other systems. So let's do that with our little example from earlier. We'll take our user and we're going to store them in a database. So here's an example of a class that might do that for us. When we construct the class, we're going to give it a reference to a Postgres database. When we create a user, we'll take the user object, we'll map it into what we think that the database actually wants, and then we'll send it to the database. Similarly, when we want to retrieve a user from the database, we'll get their email, and then we'll look them up in the database, and whatever it gives back to us will then map back into what we expect a user to look like. Now, we can't unit test this, right? Because this has to talk to a database in order for us to check that it works. And so what we would do instead of this is write a separate set of tests called integration tests. Now, unit tests would run on their own. They're super fast and they'll just like click through and give you green lights and everything feels good. Integration tests are a bit slower, and that's fine because they actually want to talk to the real thing. Integration tests are awesome. So here's a really quick example of what we might do to test our code. Here I've created our user store sort of outside of the tests. In the first test, I'm putting a user into the store, and on the second test, I'm getting them back out again. Now, I know what you're going to say. In the ideal world, we're not actually going to make our tests depend on each other. Obviously, like we don't want our get by email test to fail because our create test failed for some arbitrary reason. That makes things brittle and not great. This is just example code. I don't want to get too hung up on it. So we run our tests, our integration tests, they all pass, and we feel good about it. So now let's use our test in our code. We're going to use dependency injection to do that for us. Dependency injection is awesome. What we can do is we can create the user store elsewhere, not care about that part, pass it into our function where we're going to use it. Again, we're going to use our first time user function here. So this is super contrived. I know that it is. It's the first time we're seeing user, so we're going to store them and then we're going to return a welcome message for them. This is not good, solid design. Don't worry about it. We're just doing this for demonstrative purposes. The reason that this becomes a bit more difficult now is that we have a unit test for this, but how can we unit test it? We've now passed in a connection to a database, right? So we don't want to move this to an integration test. If we move this to an integration test, we have to move every function that uses this function to an integration test, and then every function that they use, and then it's integration tests all the way down. We don't want to do that. So what we might do instead is write a mock user store, right? Mocking is not... Okay, let's come back to what I think about mocking in a moment. Here's how we might mock something. So in this case, I'm creating a user store as sort of like a blank object. I'm putting like one method on that object that will do the thing that we need to make the test pass, and then I'm casting the object to be a user store. And total aside here, if you see as in your TypeScript code anywhere, that's a major red flag that needs looking at straight away. That's a different talk. Once we've converted it in, we then pass our user and our user store into the function, and then for some reason we're going to check that the user store was called the right number of times and that the user was stored in a store. And no, I don't like this at all, and I think there are two reasons that this is bad. First of all, we've now created a behavioral abstraction inside of our test. That's not what our tests are for, and we're going to have to do this every single time we want to use the user store, and it's going to have to be tailored to every single test. And you know, if you ever make a change, then you're going to have to change every single implementation, but that's if they even start failing, because problem number two, we don't even know that that behavioral abstraction is going to match the actual code, right? We don't know that our user store mock behaves the same way as our user store class, which means that if we change the class and the tests continue to pass because we didn't change the mocks, then the tests are passing because the code is wrong. Yeah, let's not do that. Okay, to solve this, I want to quickly talk about a different topic entirely. I want to talk about domain-driven development. Domain-driven development is awesome. I want to talk about one specific thing though. This topic is huge. I only want to talk about hexagonal architecture. Hexagonal architecture is a terrible name for a brilliant concept. Now, it's named, I think, after honeycombs, but otherwise has nothing to do with hexagons or the number 6. So put that out of your mind. What it is it's a description of how we can separate out our concerns. So in domain-driven development, you talk about your domain, your business domain, your business logic, how you think about the data that you need to deal with in your area. And then we also will need to talk, as we were saying before, to external systems that have different domains. With hexagonal architecture, the way that we break this down is we separate it out into two parts. And if you take nothing else away from this talk, take away the following two words: ports and adapters. Now, ports are how you describe inside of your program the ideal way that you would like to send and receive data. This would usually take the place of, this would usually be a interface or a trait or something like that. It usually wouldn't have any actual code. It might have code if it sort of uses those sort of other undefined functions to build up something a bit more complicated, but typically speaking, you wouldn't write any code for these. The code goes into an adapter. The adapter deals with, given this port, how do I actually achieve what I wanted to do? If I want to get a user from a Postgres database, how do I do that? So let's do a little example. We'll make our user store an interface instead of an actual class. So this is otherwise exactly the same. I've just removed all the logic. So I'm not dealing with the constructor anymore. Our create function still takes a user and returns a promise with nothing inside of it. And our get by email function takes an email address and returns a promise with a user inside of it. That describes our port, how we would like to think about sending and receiving users. Our adapter is going to, in this case, be the concrete version of this. This is going to be our Postgres example. So we've got our Postgres user store implementing our user store interface. Everything else is still the same. The constructor is the same. It takes the reference to the database. Our create method is still going to take a user, change it into what the database expects to see and send it to the database. And our get by email will take an email, get the user from the database, and then transform that back into what we think a user should look like. So that's really handy. Like, where this becomes particularly handy is if you're working for a company that decides that it wants to move its entire Mongo monolith into multiple Postgres services. And anyway, hopefully you never have to deal with anything like that, but this becomes really useful for testing. How? Well, what if we wrote a second adapter? One that doesn't go anywhere, one that just stays within the system. Now, this is a technique that was actually taught to me by a really good colleague, Stuart, who I used to work with at a company called Triptease. We called them in-memory adapters back then. I have slightly changed the name and taken some privileges, but here's basically how they work. So take our user store example from earlier. Here is the stub adapter version of that. Instead of taking a connection to a database, we can pass in an array. Now, I've made it so that by default, the array is just an empty array, but this is quite useful in case you want to pre-configure your store. We're not going to do that in this case, but I will mention it again a bit later. Our create user function takes the user, but we don't need to adapt it or send it anywhere. We're just going to plonk it straight into the array. And then our get by email function is going to use the email to look up the user inside the array and then return that. Now, it matches the interface perfectly, so we can now use this in our unit test instead of our mock. Here, we're going to create both the user and the user store. We're then going to pass those both into the function. We're going to check that the function has returned the right thing. And then finally, we're going to just check that the user did actually get stored. Now, you could check the array. I slightly prefer this version just because you're then using it in a more similar way to how you would expect it to be used. And if anything changes about the implementation details later, this should still work. So, have we fixed mocking? I would say that we have now moved the behavioral abstraction away. So all of your tests can use this instead. And as you saw, like if I go back, the actual test itself is now much simpler than when we had the mock. And we're not having to prepare this for every single version of our test and every possibility that they could cover. However, we don't know that this is going to behave the same way as our Postgres database. Again, just any kind of simple mistake here could be catastrophic. And in fact, this did actually happen to us. When we were using one of these stub adapters, it returned data in the wrong order compared to what the Postgres version did. And this was enough for us to have a bug because we were just operating on data the wrong way. Our tests were passing, but we didn't know that it was doing the wrong thing. So, how do we fix this? You may not be surprised, given everything I've told you so far. I think we can fix this with even more tests, but you don't have to write them. You already did, right? We wrote our integration tests. All you need to do is make your integration tests run on your stub adapter. Now, Jest has a quite nice little trick for this. You've got describe.each. You can pass in multiple adapters and check for each of them that they do behave the same way. You may not be using Jest, or you may not even be using TypeScript or JavaScript. You should still have a way of doing this, even if it's just putting the actual test behavior inside of one function and then calling it that function multiple times with different adapters that you're going to pass into it. Either way, you can definitely do this, and then you're testing every version of your adapters. You may even be working with a piece of software that already has multiple adapters if it wants to, say, store users both inside of memory, but also maybe inside of a database, but maybe also inside of a cache. In which case you might have two adapters that already behave the same way. And now you can put all three of your adapters in here. Your testing is much simpler, and you know they all behave the same way afterwards. So now I think we have solved mocks. We both have moved the behavioral abstraction out of the function, out of the test itself, and we now know that the behavioral abstraction behaves the same way as the real thing. So, in conclusion, I think we've learned three things. First of all, mocks are brittle and messy, and we should probably not be using them. Second of all, domain-driven development paradigms can in fact be used to help with our tests. And finally, I think the most important thing to take away from this is that I really love tests, and I really want to help you love tests as well. Now, before I finish, I actually have two bonus usages that I realized that we could use these for after we'd already sort of built them for our tests. Now, the first bonus usage is obviously in local development. Oftentimes, again, in web tech, you might be working on a single microservice, but you're gonna have to plug that microservice into other microservices. They talk to a lot of other things. So that might be databases or other APIs or whatever. So now you're gonna have to run all of those locally. You're gonna have to make sure they're all up to date and that they're all configured properly, but then they're all gonna depend on things. So you're gonna have to run all of their dependencies and make sure they're all up to date. And Have tried that and it's awful, don't do it. Alternatively, what you could do, and this is much simpler, is you could just point each of those services towards a you point each one of those services to a staging environment. Now this is better because you don't have to worry about keeping those things up to date, but the staging environment's likely to be getting alternative versions of services running in as people test them in the staging environment before putting them live. Plus people are putting lots of weird data in there, so you better hope that no one puts in any data that might break the staging environment, and you really better hope that it wasn't you that broke the staging environment, because you do not want a load of people coming knocking at your desk. So alternatively, we could just use those stub adapters. If we've stubbed everything out anyway, we can now configure those stub adapters for running locally. You could put a load of JSON or YAML files or something like that in your actual repository so that every single person running your program gets the exact same environment set up with basically no effort whatsoever. And this is brilliant. This means that you're only running the service that you care about. There is a bit of a bigger footprint in memory because you're going to have to load all of that data up, but you're not having to run it all locally, which is fantastic. And everyone gets the same behavior. And you know that they all work the way that those systems should work. So that's great. But you need to be more careful now because you have a way of starting up the stub adapters with the actual production code. You may want to use things like environment variables and other techniques to make sure that you are not running these in production, because you really don't want to run these in production. Like if you were to run your user store, stub user store in production and your web server goes down, every single user that you've stored in the store is gone. So that's terrible. You could do this by making sure whether there's a connection string in a environment variable, and then use the proper connection if there is a connection string, or fall back on the stub adapter if there isn't. And then you could also additionally make sure that the configuration file for each adapter actually exists before you spin it up, to make sure that you would much rather the program just crash when you start it up than to load up a stub adapter and then silently fail in the background at some arbitrary date in the past, in the future. So that would protect you from running it in production. Usage number 2. I'm lying to you, you can totally use these in production, just maybe not in that exact way. So where I have used them in production before was actually in a cron job. We needed to load up data from a S3 bucket stored as a CSV. We needed to filter and process that data like we would do normally with our actual database adapters. And then we would have to create a report and then record it into another S3 bucket. Now, we didn't actually need to store the data. The data actually was similar to what we already had in our storage. We only needed to do things like filtering and some very basic analytics on it. And our stub adapters already did this because that's what they were designed to do. And so we were able to drop those in. So we had these incredibly lightweight cron jobs where we basically didn't have to do anything because we had already written all of the code before. So that was nice. Anyway, that's it. Those are the bonus usages that I found. If you find more, let me know. This is normally where I'd ask you if you have any questions. Obviously, this is a YouTube video, so I can't hear you, even if you yell real loud. But there is a comment section. So if you do have any questions, please do write in the comment section. There are no silly questions. This is kind of a weird and contrived and complex topic, and a controversial one. So if you have questions, you probably won't be the only one. I've been asked questions after this talk every time I've given it. So please don't be afraid to ask whatever in the comments. Other than that, I will be back with my Idiomatic Rust in Simple Steps series in the near future. So keep an eye out for that if you're looking for Rust content. And if you've just come here for this, but you are interested in Rust, I've already started on that series. So feel free to have a look and let me know how you think it's going. Thank you very much for your time, and I'll see you soon.